Yeah, well, that's just the normal focuser in the back of the SCT, right? Or is there some other type you put on there?
Well, you would put a Crayford, like David said, like one of the. I think David mentioned a brand, didn't you?
Yeah,
Yeah,
Moonlight. It's got
Moonlight.
Yeah.
It's got a very
That goes
short.
right in the train itself.
Yeah.
Yeah, it's just
But I'm putting together the train and it just looks ugly to me. I haven't.
As long as it works.
Doesn't have to look pretty.
I think he disappeared.
Yes, he did.
He pushed the wrong button.
I think he was going to push a share button and he pushed the quit meeting button or something.
Anyways, good evening, everybody. Welcome to the August 28th Astrophotography SIG at the Victoria Center of Rask. And welcome, Ted.
Hi.
Hi, Ted.
Is this your first Astrophotography SIG?
No,
No, you invited me several months ago, and I came to one. I remember somebody asking questions about fluid dynamics of all things. And then I signed up, but I didn't realize that you had to turn on some setting to get emails from the group. So I got absolutely nothing from this until this thing, and I thought, well, that's odd. So I went poking around and I found the setting. So I have 2 emails today from you guys.
It's distributed control. So the guy who controls the list,
Yeah,
different person, and during the summer we don't have our regular meetings, so communication tends to drop off a little bit. But welcome now. Glad to see you.
Yeah, Ted, you have the custom rig that you've machined, don't you?
yes, yeah.
You've done a lot of machining and stuff.
Yeah, it's apochromatic. It's 140 millimeter aperture. I think the native focal ratio is 6.2 or 6.3. And I have a focal reducer field flattener on it, which brings it down to somewhere around 4 or 5 or something like that. So it gives me almost 2 degrees across the sky, which is what I was after. And yeah, it's worked out well. And it has a Moonlight focuser on it. So I've been using those for a long time. In fact, it's one that I cannibalized off my old SCT. I bought it originally for astrophotography on it, and decided to replace the draw tube and some other bits on it. And Ron was extremely helpful. He sent me all the bits. He charged me for half the stuff. He could have tried to make me buy a new one, but he let me rebuild this one. And so it's cheaper, better, and faster now. So, and yeah, I do mostly deep sky. So the focusing, planetary focusing is something I haven't got a clue about, but it sounds difficult to me.
Yeah.
And of course, with such a short focal length on this thing, focusing is far less critical now than it used to be on the SCT. With my camera, I'm getting something around 1.8 to 2 pixels on Focus Max, if anybody is still using that, for when it converges.
Yeah, we have that on the VCO actually.
Yeah, well, I'm old.
It is definitely old school.
Yeah, a lot of my stuff is from decades ago. I mean, it works. Why fix it? Yeah. So yeah, it's well, I've got a website that details the whole saga of why I built the thing and all that. So I like to build telescopes. I'm a bit of a gearhead, so I must have built 7 or 8 now, and I'm in the middle of building another one. So
what type, Ted?
Well, I've been doing astrophotography over 20 years, and I constantly have people show up and say, "Oh, can I look through your telescope?" No, I'm not taking the camera off. I'm sorry. And so I don't have anything else. that,
Mm.
you know, a casual person would be. So I thought, well, maybe I should buy a Dobsonian or something. And of course that turned into maybe I should build a Dobsonian. And now that's turned into how small and light can I make a Dobsonian with a large aperture? So I am just beginning to start fabrication on one that it's a 12-inch f4 and will weigh somewhere around 9 kilos altogether. The mirror being the primary being the vast majority of that. And it fits in luggage that would go into an overhead airline bin.
So it's gonna
Wow.
be it's gonna be skeletal, then, eh?
A skeletal, yeah, gossamer is the term I'm using.
Wow.
Yeah, there's not much there. I mean, the whole mount, maybe 3 kilos for the whole mount.
Wow.
All
It's
carbon fiber.
mostly mirror, right?
Yeah, the thing is the vet. I can't remember what the primary weighs offhand right now, but it's on the order of 6 kilos, 7 kilos.
Hmm.
So you know, it's 2/3 to 3/4 mirror, and the rest is the skeleton to hold everything.
Is the mirror like honeycomb then?
No, but that is certainly a possibility. I have not bought the
Yeah, it
mirror.
just seemed light.
It is insanely light, and it's using, well, you guys are probably familiar with the idea of string telescopes.
Yeah.
So what it's using is that concept, but the ideas came out largely of work that was done by NASA for deploying space structures. So there's all these truss systems and things that, you know, have to be really small, have to be really light because it costs billions to launch them. And then they have to extend out over a large area and be rigid enough to hold optical components or solar panels or whatever. So there's a great big literature on all of that sort of stuff. And so what people have been doing to some extent with the string telescopes is kind of imitating that. There hasn't seemed, from what I can understand, not a lot of overlap between the NASA world of doing that and what people have been trying to do with spring telescopes. So if you kind of blend the technologies, it's amazing how much weight you can strip out. And so it's Dyneema fiber for the stays in the system, which is bowstrings essentially. That's what they make them out of, and that's really weird stuff because it's polypropylene's been stretched all to hell, and it's stiff and extremely strong, weighs nothing. It's lighter than water, and then you combine that up with carbon fiber elements and do a bit of fooling around to make sure you don't have any more weight in it than you absolutely could do, and that's where the FEA stuff comes in.
Are you custom building the tensioners? The
Yes.
things that are gonna, okay.
Yeah, no, one of the problems, I should back up a little bit. My business for decades has been inventing things. And so I've had several businesses where we developed technology and then got it into the market. And so I'm retired now. I don't do that anymore, but the itch to invent things is still there. So the trouble with posing a question like, can I fit a 12-inch into the luggage compartment, overhead bin of an aircraft, is that puts constraints on you pretty tightly about what you can do. It's a bit like designing to the hold of a spacecraft. You're locked in, and that means that almost nothing off the shelf is going to fit because they don't have those constraints. They can do whatever works for them economically or whatever. So I've been at this about 1.5 years now, and it's 90% of the battle is trying to avoid reinventing the wheel, but unfortunately having to reinvent bits and pieces. And so some stuff I can buy off the shelf, not much. The best stuff I've found so far that helps with this comes from a source that most people wouldn't have considered, I don't think, and that's quadcopters. All these fold up quadcopters that everybody's making for monitoring their fields and stuff. There's all kinds of neat little fittings that they've invented for this, and some of those you can adapt for telescopes. And they, they have an aerospace thing. They have to be light and strong, and they work with carbon fiber. So a little bit of that is snuck in there. Anyway, I can talk all night, so you probably want to.
Well, I'm sure we'll hear about it in installments.
Yeah.
Yeah, it'll be
Well,
it'll be an installment.
it would be great if you could share your website with the group. I know you.
I
Yeah,
If
you
that's
mean
all
like
right.
actually push a share button and get kicked out of this thing or something, or
Oh, you can
no,
just
just go chat.
You can either do it in chat, or you can just send it to the group.
oh,
So this will end up on the internet. So if you want it on the internet,
well, it is. So
that's great.
is that visible?
I haven't seen it yet.
Hasn't come in the
I guess
chat.
I-
Yeah.
Oh, there it is. Yep.
Okay.
Okay, yeah, good.
Yeah, it's a joke. So I'm not very serious. No, that the project will wind up on that website eventually, but I don't like talking about stuff until I know it actually works. So
So you don't want any leaks.
it's not really that. It's just that there's a lot of fantasy out there on the internet. Oh, I have this idea. It'll, solve the world. And no, it doesn't work that way. So I'd rather roll up to a star party and unpack this thing and then everybody go, what the hell was that? Then it's real. But anyway, it's been a very interesting project, very difficult, very challenging. And I'm strongly tempted to go with honeycomb mirrors and all that kind of stuff with it, but the cost is kind of putting me off. If most of the optics out there at that 2 or 3 times what you can get just your basic Chinese GSO type optics. And so I think I'm going to go that route first, and then if maybe we'll see in the future which way I go with it.
Yeah.
So I shouldn't talk about it in this because it's a straight visual scope. If you put a camera on it, it'll weigh the whole bloody thing. So
So how's the general astrophotography been going? I guess we're back into monsoon season, or I don't know if there's any summer left.
Well, the
you
next few days
you
look
called
good.
the meeting on a clear night.
Yeah, the first good one in days.
Yeah. Well, I watched an old meteorologist. I want to run it past Reg, but he's not showing up tonight, I don't think. But he said, don't believe any weather forecast beyond 5 days.
Oh, for sure. Yeah. Yeah, like I was hoping that tomorrow's gonna be a clear night because a bunch of us are gonna go out to Cattle Point, and then now I just looked recently and it looks like there's gonna be a few clouds.
Yeah. Well, I've got everything set up to go tonight, but we'll.
Yeah, tonight might be a better night.
Yeah, I've got everything running. Just waiting for the dark.
Tomorrow looks great. Tomorrow and the next day.
Well, it's supposedly until the end of the weekend.
Yeah.
Maybe even longer, actually.
It'd be nice to have clear weather for the Saanich Fair, so
It would be.
solar telescopes can get used.
Let me show you something I captured last night. It was
Perfect.
quite a surprise.
Ah, some northern lights.
Ah,
So I was outside shooting and all these streaks started showing up. So
what time was that, Ron?
around midnight, 11 to midnight.
Because I got a message from Kirsten this morning. We're making arrangements to get together at Cattle Point, and she sent me 2 pictures, and it's Aurora
Hmm.
from Cattle Point last night.
Nice.
It's
Yeah.
gorgeous. That's really orange.
Yeah, this is the way hers looked too. There was more magenta and green in hers, like green in the upper levels.
Yeah,
Oh, yeah.
there's green.
Well, I actually have more, but I can't. Where the heck are they? Right here. Just a
Oh
second.
yeah,
okay,
yeah,
yeah,
like that, just
yeah.
like that.
Oh,
Yeah,
Yeah.
the green's supposed
And
to
of
be
course,
in the
this-
lower
this-
levels, isn't it?
Well, mid to low, yeah.
Yeah.
This was done with my modified Canon
Hmm.
DSLR, so it's probably a little heavy on the pink anyway.
Yeah.
But it was anyway.
Nice.
It was fun seeing it, and
Cool.
I was out, and it was pretty clear sky last night, so
Yeah.
I was imaging at the same time. So
I was wondering if there was going to be any flares because, like earlier this week, there was a huge string of sunspots right along the equator of
Yeah.
the sun. I mean, a huge number. Did you see them, Brock? Do you remember them?
No, I haven't looked for a few days. I didn't see those.
Yeah, huge. It just covers the equatorial band, actually.
I read something about what you were suggesting at a different meeting, David, where you said where they appear, and apparently they migrate in latitude
Hmm.
as the sun gets more active, and then migrate away.
They do. They talk about ovals. There's the ovals that occur at the poles, and when there's more extreme radiation, the ovals, it's like melting ice cream. They kind of they droop, and obviously, if we see them here, it's quite a relatively strong flare as it gets into the lower areas. But that's nice. That's a nice catch, Ron. Did you notice? Did you notice it with your eye?
yeah, oh yeah, it was quite streaky, but I couldn't see the color.
Yeah, good catch.
Yeah, it was fun.
Good job. Do you have any images you need to share? You want to share? Should say.
Well, nothing you guys haven't seen already, but where are we?
Actually, I wouldn't mind seeing them. I'm just kind of catching up. I've been so busy with schoolwork. Everything's over now, so I'm kind of coming back into the fray.
So
America.
this is the North American Nebula
Oh, the wall.
that I did last month. Yeah.
Yeah.
Mhm.
And with or without the stars, I was having fun trying to process this one, and when I got close to the end, it didn't seem sharp enough. So on my luminance, excuse me, I ran Blur Exterminator a second time on it, which I hadn't tried before, and it really sharpened things up.
Mm.
So I don't know if that's cheating or not.
Well, it's against the law, but
Yeah.
So Ron, are you using an L including your narrow bands?
I did with this one,
Okay.
with this particular one. Ones like this is purely the 3 filters here.
Yeah.
This one, and the same with the.
And are you using 6s or 3s?
I think they're
Nanometer
7s. I think.
7s? Okay.
I think. Anyway, yeah, that's my imaging for the last month pretty well.
Mhm.
And it's clear again tonight here, so
Mhm.
hopefully I'll
Hey.
capture some more.
Get some more.
Ron, were you troubled by the smoke at all, or?
No.
Hmm.
No, not at all here. Not like you guys were apparently, so.
Yeah.
Yeah.
Nice.
I haven't been as productive as I would have liked to have been. I've had camera problems. My 2600 MC was acting up, but it might be working again.
What's the status of that, Brock?
Well, I was going to send it back, but then before I sent it out, I sort of tore it down and cleaned it and reseated the ribbon cables and and it seems to be working again. So I'm going to try it
Oh,
tonight. If it
cool.
acts up again tonight, then it's definitely going back. But I got to send it to New York or something. I don't know exactly where.
It's not the oil problem again, eh?
No, it's just it's getting exposure failures. So
When you do that, I mean, I've run across it in several cases and with several people down at Cattle Point, I fixed it, and you got to go get a heavy duty USB USB cable, isn't it?
yeah, I think so.
But the
USB
ones
3.
they give you in that, I've ended up with no,
You're talking about the
flat.
you're talking about the flat cables, right?
Yeah, the ZWO ones.
Yeah,
Yeah,
the
they're
flats
no
the flats
good.
are kind of bad. I don't ever use the flats. I buy my own cables.
Yeah. No, I suspected it was the cables, and then I actually had it sitting right here on my table with a completely different 12-volt power supply, and I had about 3 different good quality USB 3 cables, and I tried them all, and it failed in every single case. So it didn't.
Yeah.
It seems that it was actually an internal issue, not the USB cable.
But
That was my first.
on your thing, that those flat cables are just useless.
Yeah.
And the other thing I found is if I try and put the 6200, the full frame, through any USB hub,
Mhm.
that just I'll get lost images all the time.
Right.
So I have to use a thick cable, nice cable.
Yeah, and actually the shorter the better too. Like
Oh yeah.
the long ones are not a good idea. Well, that's good that you were able to sort of troubleshoot that. I wonder how much of those kind of connectivity issues are a function of leaving. No, you bring your camera inside, don't you? You don't leave it outside, right?
Well, yeah, when I'm not using it, I bring the telescope in. I leave the mount out. Because it takes 2 minutes to plunk the telescope on the mount if it's already aligned and everything else. And so it seems to be the most. Also, there was another thing. There may have been a cold solder joint on the 12-volt connection. I inspected it under the microscope, and there was what looked like potentially a cold solder joint, and I reflowed it, and I realized it's pretty likely to have been because there's a ton of copper, and both of the USB shields are both soldered to that same copper plane, and so it took a ton of heat to reflow, and in the factory it's most likely that they didn't put that much heat into it.
Yeah, they're whipping through them really quick.
I got to get a microscope like yours.
That probably cost you as much as a telescope.
Well, it would if I didn't get it for free in JDS Uniphase downsizing. But yeah.
Yeah, it probably does cost as much.
I think I paid $20. Everything was $20. No matter what you wanted, it was $20. They had to have some sort of a nominal amount. So you wanted a 2 gigahertz oscilloscope, $20. You want whatever it is, $20.
Yeah.
That excimer laser, $20. Whatever. I didn't get the excimer laser. That would have been a bridge too far for my garage.
So speaking of equipment, there's been a lot of kind of talk about ZWO versus other branding now. And I've actually noticed, like, at least on the AAVSO site, like the photometry site that group I belong to, people seem to be switching to QHY. They seem to be ditching ZWO now.
Well, I have a QHY camera.
Yeah. They seem like better build. I don't know.
It's better build. It's faster. It's got the memory on board, so you're not going to lose frames. It's the cooler is stronger. It's the same chip. So that's the good part of it. The not so good part of it is their drivers suck. Like they're temperamental. I have to turn with my ZWO cameras, for example, I just turn the camera on with it connected up. The QHY camera, the computer has to be on
Yeah, that's
before I
true.
make the connection.
We discovered that with the VCO because you have the same camera as we do, and at first we couldn't figure out what was going on, and then I just methodically went through the whole thing, and I figured out, okay, I'm just going to make a map, and I'm just going to start them at different positions, and then figure out what the order is. And we finally came up with an order that actually worked, and it is a specific order. You cannot put them out of order when you start
Yeah,
them.
it's like a sports ritual. You know how you
Yep.
Yeah.
if the last time your team won, you scratch your head. So now you
Yeah.
got to scratch your head every time that your team plays.
Well, we didn't have to do that for the VCO one.
Nice.
Well, I have a boot order for my observatory as well. Same problem. If I don't fire up the camera and everything in a specific order, and the computer last.
Yeah.
Running Windows doesn't like it.
Yeah. Yeah.
You know, it all has to do with the buses on the system. And I kind of figured this out now. Like sometimes like when PCs start, some of the stuff is actually already warm before the rest of the stuff starts up. Yeah. And in some cases, equipment assumes known states before they can actually start. So if you don't do them in the right order, you're screwed.
Yeah.
Well, I have a NUC out in the observatory that has Windows on it, and I'm a Linux user, and I hate using the damn Windows. I just curse it all the time. But I have yet to take the leap to switch over to Linux to run it, because it took me so damn long to get all the ASCOM stuff working properly and everybody. And it's been happy now for a couple of years. And the only curse I have is I'll go out there and fire it up, and guess what? Windows wants to update. Which in the Linux world, of course, you have control of. So
yes,
that's one of the big things I worry about with Windows-based software is that chances are in the future an update will break your stuff.
Yeah,
it's almost inevitable.
It's done it to me tons of times, and I used to like Windows. I couldn't understand why anybody wouldn't use it, but I gradually, as my technology that I was running got more advanced, Windows just kept stealing everything. So about 2 years ago, I built myself a box with a 24 processor Ryzen thing and a microprocessor in it, and I'm running Ubuntu, and I'm a happy guy.
Yeah.
It runs like shit. It's great. And if I need to use Windows, I have this little thing called VirtualBox. And it runs inside VirtualBox, and I can keep it constrained. I can turn off its access to the outside world so Microsoft can't get at it, and then I'm interfered with while I'm doing something. Well,
anyway. Well, it did used to be on Unix, and I loved Unix, but then I was kind of forced to switch over to Windows when Windows 95 and Windows 3 came out. But now going back to Linux, I can't even remember all my commands anymore.
Well, if you're an old command line guy, I started a long time ago, before there was such a thing as Windows. I've been doing command line programming ever since, and I have to admit that going back to a Unix-like system, and they're not all the same because every distribution of Linux has got its own peculiar stuff. And you have to figure out, okay, what does that mean? All right, why don't they just standardize that? It all means the same thing. Why use a different word? You go through all that nonsense. But the new versions of it now, I'm using Kubuntu, which is what the PixInsight people recommend. And
yeah, I actually heard that PixInsight runs better on Linux.
Oh, it does. Oh, there's no question about that.
Yeah.
No, on my laptop, when I ran the PixInsight benchmark, mind you, it's an old laptop. It was 12 or 13 minutes to run the benchmark. And when I built my box with the Ryzen processor in it, I reran the same benchmark under Linux, and it was 12 or 13 seconds.
Well, I think everything's C, everything's C++. And
Yeah, I mean, it is night and day. No way could I use PixInsight on Windows with it. You know, like the image that's behind me there's 350 frames in that image, and it's a 7 or 8 panel mosaic. And you start trying to do that stuff, you need muscle and you need memory, you know, and Windows is not set up for that. So yeah, I was a happy guy when I first ran PixInsight under Linux.
Cool. Do you have any photos you want to share? We're all being shy tonight.
I could share something if
Yeah, I saw a good image of yours on Astrobin there, Brock.
Mhm.
A couple.
Let me share.
Actually, I have a few questions to ask you about your Saturn. Oh, you are going to show that.
There's a Saturn.
There's the Saturn, yeah.
Nice.
So I was saying to people, Brock, observing this, like that, like not doing any photography, I actually couldn't see the gap, and yet in yours it definitely still shows the gap.
Oh yeah.
But even at like 200 power, like on my C8, just observing it, it wouldn't tolerate much more than about 200 times. Otherwise, it just goes mush.
When was that?
That would have been 2 weeks ago.
Okay. Was that the weekend after the star party?
Yeah.
Okay, because that was when this was done. This one I took one at the star party, and then it wasn't great. The seeing clearly wasn't as good as I'd hoped it was. And then the following weekend I did this, and the seeing was just jaw-dropping. Like I just would stare in the eyepiece. I had my other scope out with just an eyepiece, and it was just like it was just this beautiful orb floating.
What was your altitude? Do you remember?
I don't recall. It wasn't. I didn't say it stay up super late, but it was getting close to midnight, I think, and so Saturn wasn't quite due south yet, so it wasn't as high as it was going to get, but is even you can see the moon here, Titan.
Yeah.
Did you use the corrector on it?
The atmospheric dispersion corrector?
Yeah.
Yes, I did.
Okay.
Yeah.
Then after you can really see the gap. That's just astounding.
Oh, it is. Yeah.
Yeah. And you can actually, there's a bit of a faint bit. You can almost see the Cassini division. Like there's a bit of a dark smudge there.
That's what I was looking at. That's what I was looking at. I thought that's what David meant by the gap.
I think
I'm talking about the
just in here
flatness of the rings.
Yeah.
Oh, I was just astounded that I could see that Cassini division there.
Yeah. And then I added it to my little collection because I have been collecting Saturns for a few years now. And I used to have this arranged vertically, but I realized that in reality, what you're seeing is you're seeing Saturn, its tilt remains the same, and you're just seeing it as it goes around its orbit. And so this seemed to be a better way to illustrate it. So
yeah, I like the depiction.
Yeah.
Yeah, that's excellent.
Yeah, it's getting really hard. Like these ones, it's easy to see the Cassini division, but my first one was before the atmospheric dispersion corrector, and I don't think I had a good camera yet either. So,
and I really like the left-hand one where you can actually see the shadow of the globe.
Yes,
that's nice.
The one in the middle, there's a pretty good shadow too on the rings.
Yeah. I wonder if the tilt variation varies over the decades or whether it's always the same.
The tilt, I believe, is the same. It's like 27 degrees, but because we're seeing it as it orbits around the sun, we're just seeing that tilt from a different direction.
But ours varies. So
well, I mean, there's a slight precession. I'm sure Saturn also has a precession, but I don't think it's
maybe not that easily detectable. Yeah.
No.
What's a year on Saturn? How many days?
I think it's 24 years. It's
oh, okay.
Something like that. I think it's like or 27 years maybe, because I think it's 7 years between when you see it at its steepest and when you see it side on, right? So that's 1/4 of its orbit. And then so you'll see it from one side edge on, right? And then it'll go around 90 degrees and then you'll see a face on kind of view, and then it'll go another 90 degrees and you'll see it edge on, and then you'll see it back around. And each of those takes, I think, 7 years. So yeah.
Yeah, I should calculate that. I remember in 1995, when I was in Australia, it was edge on in 1995.
Right. Okay. In May, or no, March 23rd, I think, of this year, I don't think there's anywhere near us that you'll be able to see it, but on March 23rd, it'll be fully edge on and you wouldn't be able to see the rings at all. So anyways, this is my Trifid, and got this, I got this one earlier on, actually. I just hadn't processed it it's several weeks ago that I got the data for this, earlier in late July, actually. So, and it's a tough one because it was, I think, at most 18 degrees above the horizon. So there's a lot of atmospheric dispersion in this one.
Yeah, it's interesting that even though it has this milkiness, you definitely have the darkness there. There's dark areas.
For sure.
Yeah.
This was without any filters, so this wasn't using narrowband. This was just unfiltered color sensors. So
yeah.
And then I got this one, which was done with narrowband on the mono, but I've got some kind of ugly purple smudges around the stars.
Isn't that normal for narrowband palette?
Yeah, I know. It just bugs me.
Oh, okay.
The stars aren't narrowband stars though, but it just when I did star removal from the actual narrowband to get rid of the purple stars, those little purple fringes didn't get taken out by the star removal. So
okay. I was just wondering if you could just do an L set of frames and sub in, like when you take the stars, I'll put back the L stars.
But the L also, I think, had those. Well, I guess the L didn't have the problem is that the color layers have those halos, right? And so
yeah, you'd have to treat each wavelength, in fact, right?
Maybe.
With the stars out, did you try inverting it and then using SCNR on it?
I didn't. I could try that. For sure. Anyways, that's all I got.
Okay.
I've got a couple of sorts, if I can find.
You were working on the veil, weren't you, Ken, recently?
Yeah, it's I don't know which screen to pick. Oh, here, I'll try this.
Yep, there you go.
Okay, this is the conjunction of Saturn and Mars. And I was doing deep sky imagery at the time, and David said that it was happening, so I just swung the scope around and did a few shots of it and processed it in pics and sites. So it was just something I picked up there.
Yeah, that's really good. I mine are not quite as good because I just shot mine with a telephoto. But this is day 2 of the closest approach. Day 1, I was able to kind of shoot something from my driveway, but it's not very good, except as a memory of what I actually saw. But it was so cloudy that morning that I waited like almost 3 hours to even see it. But they were stacked on top of each other. It was very, very cool. So this is day 2 as it's starting to move away, but still very, very interesting to look at.
Okay, this is the Pac-Man Nebula. I haven't finished this one yet, but I go in on September the 5th to get my cataracts carved out, at least from one eye, so that's going to help with the stars a lot.
Ken, you're still showing the
Yeah.
conjunction.
I'm showing what?
The conjunction still?
Oh, okay, that happened to me once before.
You
And
could
still
drop you could drop the share and just come back in. But
Yeah,
I would pick your second screen, put your screen rather than the app as your share, and then you won't have that problem.
Yeah, I guess that's my, oh, okay, got it.
There you go.
There we go. Well, that's gorgeous.
Yeah.
Okay, this is the Pac-Man. I still have quite a bit of work to do on it, but
But you
gonna
could
get
really
some
fall
RGB stars and put them in.
you could really fall into that one.
Yeah, it's kind of
It
cool.
looks very deep.
But so this area in here, when I did the real quick one for the last SIG, it was this here, and I was just kind of interested in the colors in this area here, right? I guess these are all blown up by these stars behind it, would you think?
Go back to the one you initially presented. Oh yeah, so this is the starless version, right?
Yeah.
Mm.
That's
Yeah, the
beautiful.
texture of that little dark area is really interesting.
Yeah, just floating.
Yeah, it is, isn't it?
The thing I struggle with is to, and you've managed to do this, is to not clip those brightest parts of the nebula, the stuff that's being lit up by the stars,
Yeah.
like the yellow. It like in a lot of mine, you start to see that it starts to get clipped, like it's one brightness and one color over little areas in there.
Yeah.
And like you,
So your dynamic range isn't as good. Is that what you're saying, David? Or
it's like you might not be clipping when you just look at luminance. You might not be clipping when you're looking at your colors. But when you combine your colors with your luminance, you end up with a saturation that clips and ultimately changes the color. But that clipped effect, it's just, you just got to be so careful. So you got to put them together a little dark and then brighten it up after you put them together.
yeah, I guess the sum is greater than the parts, isn't it? Like even if you kept everything level in each of the sections, just like you say, the additive effect actually pushes you over, right?
It's the problem with the hue saturation luminance model. If you think of saturation as the standard deviation of the channels, if your luminance is too high, then the high end of your standard deviation gets clipped.
Okay, so next month, hopefully I'll have some stars for you. And the same with the next one's the Cygnus Loop, which I don't have this. Oh.
Do you have Bill Blanchen's star reduction?
No. Yes, I do.
Yeah, it's really good for adjusting the brightness of your stars.
Yeah. Yeah, I have to work on it, but I think to start off with, I got to get RGB stars, right?
If you like them more, sure.
Well, I seem to have the narrowband ones, I seem to have a hard time making them look good.
Yeah.
So this is a little bit different orientation on the Cygnus Loop.
Looks really good.
I think it looks like the guy's face here and his neck and shoulder, arms, and
You're
chest.
used to seeing it the other way around.
Yeah.
Yeah,
Almost every version.
This is also mosaic as well, right? So it's a much wider field than
No.
we're used to. No,
No.
it's not a Mosaic?
No, it's been cropped a bit and I
Okay.
still have to work on it. It's got a little bit too much blue in it or something like that. And
You're
but,
just
you
using
know,
a short.
the detail's not bad. I'm gonna put in a lot of time in on the narrow band on this and maybe put the two together.
Hmm.
But it's picked up a little bit of the shock wave in that.
Mm-hmm.
Nice.
What is the focal length on this, Ken?
It's the ASCAR 107.
Oh, okay.
How'd you fit it in one frame?
Well, that's what I'm saying.
Yeah.
It looks like a Mosaic.
Oh, I'm sorry, it wasn't the 107. It's Red Cat 51.
Okay,
Okay.
that makes
Oh,
sense.
Red Cat. Okay,
Red
that makes sense.
280 or something, isn't it?
Oh, the Red Cat. Oh, yeah, yeah. It's short.
Yeah, I put the Hyperstar on the 8-inch, and you know, of course, I have problems with everything I try, right? But
Yeah.
and then I got the Red Cat going. I thought I'd throw it up there, and now I really like that, so I just yanked the Hyperstar off, and I'm trying planetary, and I may be yanking that off and going for deep sky on the 8-inch.
Nice.
Brilliant. So you gotta put the stars in that one, or you?
Yeah, no, I got to make the stars up, and I'll put them in.
Hmm.
And I'll also have one with them out. I kind of like a bunch of these with the stars out, right?
Yeah.
I'm not a purist like you, Dave. I'm an artiste.
Can't you see the beret on Ken's head?
At least you didn't break the law like Ron did.
Yeah.
2 iterations. Yeah, it's terrible.
Oh.
Evil. Trump.
All right.
I'd give her 4, Ron. So that's me.
David?
Nothing except for those short shots, and they're not really anything to look at. They're more I like to think of them as kind of like just memory things. Like I in fact I've gone really lo-fi the last month or so. I've been taking pictures with my just with my phone and stuff like that. So nothing really to show. I've been actually working on my my mounts actually. I've forgotten how much I've forgotten.
Yeah.
I started a whole bunch of kind of revisions of my mounts, and I still haven't completed the one on the GM8 yet, but I decided to use it. Like I haven't had enough time to do the full revision on it because it requires a firmware switch, which requires programming these EPROMs that are actually on the controller. So I've decided to just use it for a little while and wait until it's really bad weather and then work on the revision. So I've been basically just redoing or refitting my kits. The biggest problem I seem to have, because I don't have a permanent setup, is I have these crates full of stuff and it's just such a mess. I mean, it doesn't start out being a mess when I go to like Kettle Point or go up to the hill, but when I come home, I'm so tired, I just throw everything in the box and everything's mixed up.
Yeah.
Right.
So I've been spending a lot of time trying to figure out the exact kit, and I bought all these little boxes so it can be orderly and that I don't have to kind of get mixed up, because I always find I'll forget something. I'll forget a cable or whatever, right? So I'm working really hard at building optical setups so that they are crated and boxed, ready to go. So I don't have to kind of figure out at the last minute. And then of course I would forget something.
I learned that from Ron, like everything's together all the time.
Well, you know, that's what a lot of people have been saying to me, and even Ken was saying, don't build it when you get to the site. Pre-build it,
Yeah.
and then just pull it out of a box.
Just
right?
get a bigger box. Yeah.
Yeah, I mean it makes so much sense. And then all you do is just check it when you
The boxes that the telescopes come in, sometimes they give you a nice, metal box or a nice
yeah.
cushion box or something. Well, they end up being useless, and they're all stacked in my garage because
Mine's I've sort of standardized on kind of backpacks, and the only reason for that is being a photographer, that's how I work. Because like if I have to do a shoot, I will pick all my equipment and I'll throw it into my think tank backpack, and it's just what I need, right, for the day. So I'll just push everything in. So I've started out that way with astronomy, but I found that there's so many little bits and pieces. It's kind of working against me. So I think I'm more inclined now to build the whole optical rig and then box it, and then just pull it out and use it, right? Because it takes up so much time to cable everything up, and it just doesn't make any sense, right? I need some of the benefits of the people that have constant setups, right? And one way to do that is to basically rig it and just box it, so just one piece, right? Yeah, so that's what I've been doing. I've been busy kind of figuring out boxes or crating so that I can get it right. So my test is tomorrow night. I'm going to go out to Cattle Point tomorrow night. So let's hope that the configuration works.
I'll come down and inspect it.
Yes, I'm sure Ken will.
Forecasts
Well,
are looking pretty good.
I will share an image, and I've got a story to tell along with it. And you might find it interesting.
We find all your images interesting, David.
Amen.
Am I sharing?
You're starting to.
Yeah,
there we go.
You are.
Okay. Okay. So I hope you can see this. This is actually on Astrobin.
Did you do flash back and forth between two versions, or?
Yeah, that's why I'm showing
Okay.
the Astrobin version, because you can do a mouse over effect.
Oh yeah, okay.
So this was a dark nebula that I saw. Initially, I saw it, and it didn't look like this, and I'll tell you why in a second. But they had added some hydrogen alpha to it, which added a bit of dimension to the normal dark nebula images.
Mhm.
And of course, I wanted to do it to a bit of an extreme. So I took my LRGB frames, and I also took a lot of hydrogen alpha frames. And then I discovered that when I did my continuum subtraction, that all the dark nebula was essentially black in my hydrogen alpha frames.
Mm.
So if you know a little bit of radiation fundamentals here, so hydrogen is a gas, and it's fairly warm when it's emitting hydrogen alpha. And it's actually a change in the orbital of one of its electrons that gives off, well, its only electron, when it gives off the hydrogen alpha spectrum. There's various electrons going from one orbital to another orbital, will give off any kind of light, some generally UV, and you don't see it. But in this case, the Balmer series involves an electron ending up in the second most orbital out, and going from the third orbital out to the second orbital out is what gives you that red color. So that gases don't do much, right? In order to absorb more of a spectrum, the substance has to be a condensed phase. So that means it has to be a liquid or a solid or a plasma. So what the reason for that is that light absorption can take place over a wide variety of frequencies when the molecules are right next to each other in a substance, as they are in a condensed phase. So they can rub against each other. So they can convert photons into kinetic energy by bouncing and rubbing against each other quite easily, and vice versa. So that's a clue of what's going on in here. So there is a little bit of LRGB in this image, but I took that continuum subtraction hydrogen alpha and I really emphasized it. I made it the dominant color, and I made it the dominant source of luminance in the image. And that's this image here. And what you can see is that all the hydrogen alpha emissions in this image are actually coming from the far side of the dark nebula. Now, the dark nebula is dark for a couple of reasons. The main reason is that it contains condensed material. Initially, that's dust, just heavier elements that at the prevailing temperature and pressure are generally solids. So they'll block any light that's coming from this hydrogen alpha backlit, and you see wherever that condensed material is shows up black. When it's thin, it's smoky, and when it's thick, it's pitch black. And sometimes there's little holes that it peeks through. But this is a molecular cloud, particularly this reversed L-shaped thing over here. It's what they're calling cloud collapse. So not only is the dust blocking light, but the hydrogen in there, mainly hydrogen, there's some helium too, but mainly the hydrogen in there is condensing too. So this is where I sort of read, and everyone sort of sloughs off it in textbooks and books that kind of say, well, the cloud collapses, and often they say by gravity. And that didn't make any sense to me, because why is gravity going to cause hydrogen to come into a dense state in order to form a star? So I did a little bit of research on it, and I found out that, well, at the temperatures and pressures stated in a molecular cloud, particularly one under collapse, hydrogen is a liquid or a solid. It's well below its critical temperature, and it's going to freeze or form a liquid. So usually in the clouds in the atmosphere, you've got dust particles or aerosols that form nucleation points. Well, I believe that the dust is forming a nucleation point in these molecular clouds. They're serving to block off the light, so these get really cold. And it's typically quoted that the clouds get less than 10 Kelvin, so really, really flipping cold, in order for stars to form. So there we have it. We've got hydrogen forming initially a dew or a frost, you might call it, or small hail particles within these clouds. And that's further blocking any light from reaching the cold, cold interior. And if you can imagine these clumps of, tiny clumps initially, of condensed hydrogen bumping into each other and and aggregating, eventually there's no gravity to pull it away as hail or rain or snow or anything like that. Eventually it will accumulate to a size where gravity can take over. And this solves a main problem with the often quoted method of star formation, is that if gravity was pulling the hydrogen all to a center place, the temperature rise would essentially push it back away from each other again. But with like just like water freezing, hydrogen condensing will give off that heat, but it'll give it off in a distributed way. And given the temperatures, that way of getting heat removal would be via radio waves, 10 microns and longer, which not even the dust is going to block from leaving the condensed cloud. So, you know, by playing with the parameters in the image, it sort of spurred on this investigation into what's going on in the early parts of star formation during the conception of a star. So if I zoom off of this, you'll get a much more moderate amount of hydrogen alpha in the image. And what you can see is now the foreground. So these are stars and reflections coming off of the front side of the dark nebula. And it's more like a dark nebula that you'd be used to. You can see certain sort of things. If I go back and forth, there's a brightish nebula right where my mouse cursor is. I move it away and it becomes quite bright as it's lit up by the starlight that's in the foreground. You'll see a halo around this star that disappears in the hydrogen alpha. You also see a light leak that does too. But it was really fun to look at. I can actually show you another image, which has essentially the hydrogen alpha taken out of it for the most part. And you see the red filter still captured the bright of the red, but now you see the dark nebula more normal. And up in this corner was a freebie bonus. If I can zoom in on this, you see there's a star emerging from this cloud. There's a Herbig Haro anyways, coming out of that dark nebula. And I can tell that it's this side of that dark nebula, because if I go back to the hydrogen alpha version, you can see how dim it is in hydrogen alpha. So I know it's this side of that molecular cloud, not something going on in the back. Anyways, I thought it was an interesting story. If you want to know more about that science, just ask.
Nice images.
Mm-hmm. Yeah, it's kind of interesting. Along with the narrative, it's kind of interesting to see that layered effect explained.
Yeah. Well, there's a lot of digging around on the composition of stars that I did.
But it actually shows a lot of sleuthing as well. I mean, like noticing the emerging star and noticing some things that would give you a clue as to what's actually happening.
This is the the phase diagram is pretty boring. It's on a log scale, so I'm not used to log scale phase diagrams, but with hydrogen, we're dealing with such low temperatures before anything interesting happens. But here's the phase diagram. So it's really out here where you'd be talking about so the ideal gas law holding, and down in here, when you're close to the critical point, it's more the van der Waals forces that start to dominate gas molecules colliding with one another. So out here, it's like an elastic collision, but when you get really cold, it's like the molecules get sticky. So the collisions become more plastic, and the collisions generate heat instead of instead of just bouncing and conservation of kinetic energy that way, and conservation of momentum. And then as it gets even colder, that stickiness increases and causes the condensation of hydrogen. So it really is a different, and I think it's kind of understated, and I think it's the reason why it's generally called collapse under gravity, because gravity does take over at a certain point. But I think it's just an oversimplification that's made for public consumption, if you will. But here's the same diagram, but it's over, and this is a Russian diagram, but it's over much larger pressures, atmospheric pressures down at this 5. So this is higher than atmospheric. But you still a phase diagram that a hydrogen star has to travel through. So where I was talking about is probably down here on further to the left corner, where it all can turn into a liquid or a solid, even at very low pressures. But somehow, when gravity starts to take over, the hydrogen will start to be compressed into the star and will start to heat up. So the critical thing is that gravity is stronger than that pressure generated that will disperse the star at that point. But it would rapidly go into not like a normal gas that you would see, would become what's a supercritical fluid at some point. And as the temperature rises, it would go to an atomic fluid. In other words, the hydrogen atoms would, as it gets hotter and hotter, the atoms would dissociate, the molecules would dissociate into atoms. And then a really weird thing happens to hydrogen. It turns into a liquid metal, like mercury, right? And on this diagram, it's got plasma versus metallic liquid over here at higher pressures. I'm not sure where a star is on this diagram, whether it's on this side or this side. But my understanding of a plasma is that's when the components of the atom all dissociate with another. Well, in order to be a liquid, a metal, it says that, well, you've got nuclei that dissociate their outer electrons, and they're kind of in a sea out of electrons, and that's why they're conductive, because there's these electrons. Well, hydrogen only has one electron and only one proton. So I don't see what the difference would be between a plasma and a metallic liquid in the case of hydrogen. They're both the same thing. So anyways, that's what the sun is made out of. That's what the bulk of the sun is. It's actually a glowing chunk of liquid metal.
Could possibly the plasma be a compressible state that's still more like a gas, and the metallic liquid becomes more like an incompressible fluid?
Liquids are somewhat compressible, and I imagine plasma at high pressure would, maybe that's it down here somewhere. Maybe that's what they're getting at.
Because you go through a sort of a phase transition though between like, even though solids and liquids typically are compressible, they're nowhere near as compressible as a gas. So you go through a serious phase transition between the compressibility
Well, that's
of
the
a
difference
gas.
between a liquid and a gas, right?
Yeah.
I mean, out here, gas only exists up to this pressure.
Yep.
Above there, it's actually a supercritical fluid. So it's neither a liquid nor a gas.
Yeah.
It will turn into a gas, not through a phase change. It'll just turn into a gas if you drop the pressure, but it'll turn into a liquid if you drop the temperature. So anyways, that Herbert-Harrow you saw, I think, is the dynamo caused by angular momentum in this protostar generating a huge magnetic field and squirting out material out of the poles. And as this collides with other material, it starts to glow because of all the heat generated. And these things actually leave the protostar, apparently. Like they physically leave the protostar and go wandering about a light year or so.
Wow.
So is there a type of erosion that occurs? Like pieces of it start flying off? Is that what you're saying? Or
no, they're actually jets that come out of the poles.
oh, right.
But then they detach. And so you'll see Herbert-Harrow without the star. And you sort of look in the neighborhood for the right star. But anyways, I'm wandering off the topic, but I thought it was fascinating, when an interesting rabbit hole to go down. Then, of course, I went into a different rabbit hole. Where is this? Having to do with supersonic explosions, like happen in a supernova. And after getting over, well, what's the sonic velocity in space? It's got to be at max walking speed, right? Because it's so compressible. So it all has to do with, is the medium moving along with the front, or is the medium static when this explosion? So you have to get a sharp pressure front at the front, but then the explosion has to stop fairly rapidly too, in order to get a sharp front at the back end of this too. You create a vacuum behind the shock front, essentially. But this is a supernova remnant. It's really faint. It's in Cygnus. Some call it the little Cygnus loop, but it's bigger than the Cygnus loop, so I don't really understand that.
Whereabouts is this in Cygnus? Is it near Sator or closer to Deneb?
Right there. It's near the.
Oh, it's just away from Deneb then.
Near the head.
Fail. Okay.
The goose's head.
Yeah, near Deneb.
So it's not too
Interesting.
far from the Vale, because that's just over here on the right wing.
But it's not part of the veil, though, right?
No.
Oh, it's just a little up from Vulpecula.
We don't know where this,
The fox.
sure.
Yeah.
The star is somewhere around here. But no one knows exactly where it is. But you'd think it would come out in a nice perfect sphere, but as this shock wave encounters various densities of material along the way, might even encounter a star that's going to cause interference problems. The shock front will reflect off of stuff, and that will generate radiation and the whole gambit. Like this one is really strong in O3 data, and often some of the streaks seem to turn from O3 into hydrogen alpha, and some are hydrogen alpha and some are O3. And I think this has more to do with the strength of the UV light that's hitting it, or that's being generated by it, I should say, because I don't think this is being lit up by stars. I think it's being lit up by its own energy.
Oh, do you think it's emitting it? It's not reflecting it.
Well, yeah, either way, it's emitting it either way, but it's not energized by UV from stars. I think it's energizing itself from the heat generated at the shock front. Anyways, so that's it. So I went on a bit of a tear, and I've been looking at supersonic things.
Very nice.
Which got me into another rabbit hole looking at the supersonic spy planes from the 70s, which I remember looking at when I was in Air Cadets. But that's another story.
Yeah. Slightly different speed of sound, though.
Yeah. But the principle should be the same, right?
Yeah, it is. I remember looking up the mean free path of these gases in quotes, and it's like thousands and thousands of kilometers. It's just ridiculous.
Yeah. But it's still, I think the average collision rate is a couple of minutes.
Okay.
In a diffuse cloud.
Of course, temperature dependent because that's velocity. So
Yeah.
Can you say that once again, Dave?
A molecule will hit another molecule every couple of minutes in a diffuse cloud.
Oh, okay.
And that's probably about 150 Kelvin. But in a collapsing cloud, it's like single digits Kelvin. So it's really, really cold.
And same number of collisions?
Well, it's really hard to tell what the density is and what the pressure is. And I'm sure it varies all over the place. But I think they're also influenced by external pressures on the cloud.
Yeah.
Which is why I think you see lots of star formation in like the pillars of creation or the finger of God or the elephant trunk and stuff. I think the process is getting sped on its way by the pressure put on the cloud from the radiation and stellar winds from stars that have already been created. So it might take you a while to make the first couple of stars in a cloud, and then they probably rapidly form in a cluster after that, relatively rapidly. That's just me. I'm not I don't have a degree in astronomy or anything. So.
You better go get one.
Well, I don't know. I don't know how much the bank would trade it in for. I know I'm not going back to work.
I've got some expertise in acoustics. And so it's really interesting to me listening to essentially what I would think of as acoustical phenomena operating at 10 Kelvin. And, you know, with all these exotic materials, right? I'm used to, you know, 330 meters per second. That's your given speed in air. And, but phenomena are remarkably the same.
I'm the same way. It's high pressure, high temperature stuff, right? It's that's what I'm used to. But then I'm either confronted with much colder and much less dense than I'm used to, or pressures that are beyond reason.
Yes. Well, I'm mostly used to making music and studying acoustics.
I have a bit of a background in high vacuum plasma and
yeah, I mean, everybody's world is a little bit abnormal, isn't it? It's
well, if I say anything wrong, Brock, just let me know.
Well, I'm intrigued by the cooling mechanism because I hadn't thought about the transparency of the media to radio waves as a means of getting that latent heat out of there. And so that you could get the collapse and you could get condensation going on without compression effects heating it up.
Yeah.
That's a new one on me. I never thought of that before.
It was a combination of that. So I looked up what 15 Kelvin, what the peak is at 15 Kelvin, and that's 10 microns. So that's kind of on the verge of microwaves, but more into the radio, and colder would get longer than that. But the other thing is, what I found it like, even if it's just compressed under gravity, there would be a lot of heat generated in that case too, but it would be focused at one point. But if you have condensation, like in a cloud, it's distributed over some volume of the cloud. So there isn't that concentration of heat. So.
Yeah, I've still got to get my head around all these triple points for hydrogen and stuff, because it's just not a world I know much about. But
yeah, it's 33 Kelvin.
It's interesting, though. I mean, I'm not sure how much it has to do with astrophotography, but I was real interested.
Well, it's sort of there was a debate on Astrobin once of whether astrophotography was strictly an art or whether it was an art and a science. And you know, I was no, I got into it because of the science, because I haven't got an artistic bone in my body. So you know, I just love doing the astrophotography and trying to figure out what the heck's going on in this image, what's creating that that sort of thing. But you know, in a molecular cloud, in that dark cloud, well, no one can prove you wrong. Because no one can see in there.
Well, never say never. But the important thing is it gets people thinking, right? I just, you know, I'm looking at images of things that I've taken now, and I'm thinking more about, well, I've always been interested in the processes. You know, I've got physics in my background, and so I don't sit there and not think about it, but I do think more about whether it's pretty or not. And maybe I should be thinking more about the science.
Well, I think whether it's pretty or not too. I just don't think I'm a very good judge of what's pretty or not.
Yeah, well, that's the rest of my family are the artists, so if they like it, it must be pretty.
The best of both worlds.
Yeah. I have a question maybe you guys can help me with. Look at the image behind me that you can see that I've used for wallpaper. You know anything odd about that?
Well, the stars look like little,
Well, there's way too many stars in it. Yeah, I
but
haven't.
they all
Is it?
look like lines. They don't look like stars. They kind
Is
of,
it a
but it could just
JPEG?
be the compression.
It's Pelican and North American Nebula, isn't it?
Yes, it is.
Yeah,
Is
I
it a
can see the
JPEG?
Pelican.
Yeah, but it's backwards.
Oh, okay.
It's been inverted. Now I have that image on my screen looking at it, and it's the right way around, but that's reversed.
Oh, right.
Yeah.
All right.
I never
Well, to
noticed
me, it
that
looks-
before.
Well, the Pelican's facing the right way, isn't it?
Yeah, it looks.
Well, the
normal
view,
to me.
what you
Huh?
see in your view on Zoom is what you would see in a mirror of yourself. So
Yeah,
you're not
yeah.
seeing
Yeah,
you the way
okay.
everyone else is seeing you.
Yeah.
Everybody else is
yeah.
seeing it normally.
Yeah,
Okay.
yeah,
Yeah. And so
I knew there had
they
to be
did
a
it that way
logical
so that if you
explanation.
think your hair is messed up, you,
Yeah.
because if it wasn't like a mirror image, it would be really weird for you to, like, before the beating starts and you go, oh,
Exactly.
checking out your hair. So
Yeah, it's a mirror
they do
image. No,
Well, it's sure nice to have all the expertise
Oh,
around.
Mhm.
see, I'm still as stupid as I think I am. Thank you for that explanation.
But
Well,
the
camera
Pelican
is-
the Pelican's very recognizable. Actually, I was looking for the wall, but I guess that's on.
Oh, I think I'm in front of it.
Yeah, you might be
Yeah.
in front of the
Yeah.
wall.
But I
Yeah.
think the camera's doing something with your stars.
yeah.
What? There's too many of them.
No, there's
no,
compression
no.
artifacts.
I don't know
They-
if you're looking at I don't know if you're seeing what we're seeing, but the stars are kind of amalgamated into stripes.
Well, that's just
That's
that's just
a
resolution, I think.
Zoom thing, I
Yeah.
think.
Yeah, I think it's
Yeah.
the zoom thing. or
It's
the
probably
camera.
compression. I would think it's compression.
Dave, your stars also look the same.
Do they?
Yeah.
Because
You don't have as many stars, but they all kind of,
they.
they have there's definitely a compression artifact of some
Oh, yeah,
kind
it's
that's
compression.
making them kind of
Yeah.
look strange.
Yeah, I'm only seeing a very small image here, and my eyes aren't great, so I can't tell.
Yeah, it's compression.
Yeah. I mean,
I
that's
might jump out of the meeting to go and screw with my telescope. I realized it's still focused as if it was doing planetary, so it doesn't have a hope in hell of doing anything.
Where
'Cause I just
when are you going to the Spanish Fair, Brock?
Sunday 10 to 2, I think.
Oh, okay.
I'll probably bring the center's solar scope.
Well, I'll see you there because that's my shift too.
Oh,
No,
you're gonna
you're
bring-
You're Monday, aren't you, Dave?
Monday. Didn't you say Monday?
I said Sunday.
Oh,
No, I'm with you.
oh,
I'll be
who's
there on
you?
Monday.
Oh, you're okay. Monday.
The
Yeah,
Daves
I
the
just-
Daves are there.
The Daves are together.
I
you
didn't
gonna
know
bring
what
your-
the plans were or anything, so I'll just
I
pop in
only have
someday out
white
there.
solar, so I'm
Right.
assuming Dave will bring his H alpha.
lunt.
yeah.
Oh,
Yeah.
that'll be good. Yeah. I
That'll be
might
the
come
combo.
just on Monday just to look through your lunt. It's so good.
Because it's
Coronado.
cloud dependent.
Well, yeah.
Yeah, Lunt's nice. You have a double stack, right?
Yeah.
Yeah, actually, it's going to be kind of cool even in white solar. Like I said, there's this string of sunspots running through the equator right now.
Maybe I'll.
I looked on the
Maybe
weekend
we'll
and there was
come.
quite a few. So
I greased my mount.
Oh boy, how did
On
you
the-
pick? How did you pick the lubricant?
I phoned up Astrophysics.
And you asked them, eh?
Yeah. And they actually mailed me detailed instructions.
oh, nice.
I'd
Mm.
never gone into it before,
Yeah.
which was handy. So it all works great, but it's
So are you forced to use solvent to strip everything out first, or you
No.
don't, eh? Okay.
They say to do that if it's particularly dirty, and I was prepared to do that, but it's such a hassle because you have
Oh
to
yeah.
clean it and then you have to rinse it in isopropyl or something else, and so I just used a toothbrush, like wiped up, used a toothbrush to get in the gears, and it came out.
Nice.
Yeah.
really.
What kind of
it-
grease was it that they recommended?
Something 33 or something.
The Losmandy mounts they used to recommend super lube, which is super common, which I was really
Yeah.
happy about. But
I-
now they say no, you should use jet lube, and that's hard to get. Jet lube is really hard to get.
I don't know.
Hmm.
It's greasy.
It's greasy.
But the only thing is it makes a little bit louder noise now,
Hmm.
Yeah.
slewing than it did before.
Interesting.
Is there? You use worms still, right, in your mount?
Yeah, I don't think the noise is from the worm though. I think it's from the gearing that happens before the worm.
It'll be the
Oh.
transfer gears, yeah.
Okay.
When I rebuilt my mount, I stripped out all the transfer gears and put in belt drives.
Mm.
Oh yeah.
Yeah, and the mount just went silent when I did
Yeah.
that.
Oh yeah, it would.
You got spur gears in there that are, there has to be a certain amount of clearance in there, and that's what makes the noise.
As they hit each other.
And with that clearance, there's probably inherent backlash as well.
Yeah, there
right?
is. That's going to be where some of your periodic error comes from, is from that.
But not when you have
Absolute encoders.
absolute encoders.
Yeah, that's a little bit
In
different.
which case it doesn't matter.
Yeah.
But part of the trick that telescope mount makers do is they put a lot of grease in there because that makes it quiet.
Mhm.
And
Yeah.
people who rebuild don't want to put so much grease in there because they don't think it's needed, and therefore it's a little noisier. But
That's my situation entirely.
Well, that was true of cheap photographic lenses as well. Like they were a lot cheaper, but when you bought them, they were really nice. But after a couple of years, they went kind of gritty.
No, that's the old Chinese. Let's put lots of grease in there; it'll be nice and smooth trick.
Well, this was astrophysics, so there wasn't a cheap mount.
No, well, it isn't. It isn't about whether it's cheap or not. It's you just have to have those clearances, and they make noise, and people don't like it. They don't think that should be right, but that's gears. Unless you put it in an oil bath or something.
Banana peels.
I have a thought. As far as I recall, astrophysics was using belts, but I could be wrong.
Well, you have a director. I've got two of their mounts. The older mount is gears, and the second one I think is direct drive.
Oh, is it direct drive? Okay.
Yeah, I believe so.
Direct drive is nice if you can get it.
Yeah, that would be. Okay, I gotta go, guys.
Okay, good night.
Thanks.
Yep. Good luck.
Well, I think I'm probably going to head out too. I forced my wife to put something on pause on the TV here, so
I think you've been gone too long.
yeah.
Does anyone have anything for anything else, or should we wrap it up? Or
Yeah, I have to get going too. There's a few things I want to tweak before tomorrow night.
so anyone want to bring up anything else, or
Well, I do have one thing. I just updated PixInsight on my Linux system. I don't know if any of you are running Linux, and the bugger won't run.
Oh wow.
There's something about, I think, about Sandbox in Linux that's causing it not to work. And so I put a message up on the chat room at PixInsight, and nobody responded to it, even though lots of people read it.
So are the upgrades done in the same way in Linux, or do you have to go to the command line to do the changes?
A little of both. There's software that allows you to do it, but I usually do it directly from the command line because I know what I'm doing. And obviously nobody knows the answer to it, but I'm perplexed because usually PixInsight's very good at helping with this.
Well,
I wonder if the community is not that high.
I did the upgrade with PixInsight there, and I've just been fighting it ever since. I'm thinking about dumping it out of the machine and reinstalling it, but things like image solver, I'll turn image solver on, and it will crash the computer.
Yes, I've got that very same thing.
Another one would be, what else does it do? Oh, there's a number of things I'd have to think about it, but you know, there are several problems, and I thought it was just the upgrade.
I think it is partly the upgrade, because I think it's not. I don't think it's clearing its memory properly.
You know, in the worst case, you can just scrub everything, work from a base, and not work with any kind of add-ons or whatever, and then just put all your repositories back in. You could do that.
I think the problem is when you've been opening a whole bunch of images and you've used up the memory, and then you go to the image solver and it crashes. Because then when I load it up again with cleared memory, when you start it up again,
it's fine. Eh?
It's fine. But that whole Pix Insight update thing is just like, we spend a lot of money on that software. And
well, at least you don't have to. At least you don't have to pay for upgrades. I mean, I think it's a bargain actually, because I mean, a lot of my other software, you have to pay an annual fee, right?
But every time you upgrade, you have to get all your scripts and reinstall everything again.
Well, the repositories and that should still be there. And the problem I had with the upgrade with this one was also the modules. So whenever I rebooted Pix Insight, the modules wouldn't be there.
Exactly. That's what
like GHS and that. So I had to go down to modules, the bottom of processes, and say install modules and do a search for them. They'd pop up and say install, and they'd be back there.
Well, I'd have to download them all again.
No, it did. Well, did you try that route?
Yeah, and when they're not there at all, I have to go and download them again.
Oh, okay. Well, I did a search and they popped up. There they were, and I reinstalled them.
So now I keep another directory that's got all my stuff that I want to be in there.
And you guys are kind of computer guys, you know. I'm kind of screwed when it comes to all this stuff.
Well, I'm not doing that right now.
I remember with this business not to get frustrated.
I'm gonna let you guys go, and because I need to get back to what I was doing before. So.
Yeah. Well, thanks, guys. We'll see.
Okay. Well, thank you. Very interesting, Dave.
Either see you at the fair, or at the the cafe, or next month.
I thought you would have showed us your mosaic.
This was a mosaic. That was a 2x2 mosaic.
Good night, Bruce.
Night, Bruce.
All right.
That was a mosaic, Ken.
Yeah.
That was a 2x2 mosaic.
Oh, okay.
That's how big that sucker is.
Yeah,
Yeah, I'm pleased you're having so much luck with your harmonic drive. That's good.
Oh, it worked well.
Yeah.
What sort of guiding do you get on it?
0.5, 0.6.
That's just like the AM5s, just like
yeah. I mean, I've been down to 0.18, and quite often it's just between 0.2 and 0.3. And that's with a 120 guide camera on her.
I still don't understand how it could work, except that I know that like my 290 has tiny pixels, right? I think that's how it gets away with it, because the pixels are tiny, right? Like if you didn't have tiny pixels, you'd have to have a bigger guide scope. Undoubtedly, I think you'd have a bigger guide scope.
Are you running an off-axis guider?
I'm not. I'm just running a separate little guide scope.
I was just wondering if Ken was with that.
No. It was a guide scope.
Same as mine. The stock one.
240mm or something.
Oh.
Yeah, the stock 120/4. Actually, Ken, I was thinking about moving up to the William Optics 50 guide scope, actually, just to get a little bit more aperture.
Yeah, well, both my other scopes have 50.
Did you get the
50
William
or 60?
Did you get the William Optics one, or did you get the Skywatcher ones?
Probably Skywatcher.
Nice thing
I
about
just
a
tell them
guide,
to send me something, right?
nice thing about a guide scope is you don't have to recalibrate every flipping time you move the camera.
Well, like
Well, I had so much problems with that off-axis guider. I mean, it was a learning curve, and there was a camera problem, and blah
Yeah.
blah blah. Right?
Yeah.
and you don't have
I just what the hell am I going through all this for?
and you don't have to worry about dark filters either. I mean, it's totally separate, right?
Yeah.
That's
So I'm going to
what's
put both of them on my 8-inch. And, I'm not going to let the off-axis guider defeat me. But I'll have the other one around too, and I can just switch them around.
Yeah.
It shouldn't hurt to have the off-axis guider there.
I mean, the big reason why people kind of diss the separate guide scope is because of flexure and stuff like that. But if you've got a very solid guide scope, and they've really changed the way guide scopes work nowadays, they're very solid. Like everything's screwed in, and there's no set screw points or anything like that. So I don't think there is really much flexure involved. I don't know. There's pros and cons for sure. The thing
I ask you, Dave, too, with your mosaics, how much overlap? What percentage overlap do you give them?
I think it's 10. Whatever Nina tells me.
Yeah. If you go up to 20, and they even say 25, right? But that seems like a waste of an awful lot of pixels. But around the 20 mark, then you run into those bright stars around the edges. You
Yeah.
can just eliminate, to save the best star and just eliminate the one below it, right?
Yeah, I think what was going on with mine was the gradient calculation. There used to be some guy, I can't remember his name, wrote the original mosaic stitching program. So it was a 3-step process. And then PixInsight said, okay, we want all the contributors to sign their programs. So we did that for GHS.
Yeah, certificate signed them, right?
Certificate signing.
Yep.
But the guy who wrote the mosaic stitching program didn't. And it caused refused to do so. And it caused a bit of friction. And then PixInsight came out with their new gradient removal tool. And they thought this was such a fantastic thing that they turfed the original, somehow they turfed that original stitching program and put in their own gradient, it's called gradient mosaic, whatever process. And it's not as good.
Can you still get the old one though?
Well, I from what I saw, it did a pretty good job of everything, right?
Well, you know that artifact I was showing you in my Cygnus loop?
The one I pointed out?
The one you pointed out. That
Yeah.
was bothering me. That star wasn't removed in the star removal process. So I had to put the gradient with it in. And it created, on one side it said, oh,
Yeah.
you've got this halo, and on the other side it says there's no halo. And
Yeah, but that's just in one frame, right? One pane.
no, it's along the seam.
Yeah, along the seam. What I'm saying is, if you could, is there a cut process in PixInsight? I haven't been able to find one.
Well, there's the clone stamp.
Yeah, well, you can use the clone stamp is what I use, but I know you hate the idea of it.
Yeah.
But just eliminate one of the stars.
Yeah,
Oh,
no,
you
That's
mean
it's- the
before you
stars-
stitch?
The
before you-
stars overlap perfectly.
It doesn't make any difference. That's where you're picking up, that's where the gradient problem's picked up.
Oh,
So Ken,
okay.
you're saying take one star out before you stitch, right? So there's no confusion, right?
Yeah,
Yeah.
Okay, I should try that.
Yeah, that makes sense actually. We do that actually when we do panoramas, like when we do terrestrial panoramas. We line them up like in Photoshop or Lightroom. And when you look at them, if there's something that's especially difficult, you get rid of it on the adjacent pane, and then it
Yeah.
doesn't have any trouble, right? It
Right.
integrates it.
Okay, now that makes sense.
Yeah.
Never thought of that.
Don't make it any more confusing for it than you need to, right?
Yeah.
Hell, you got 24 hours of processing and already give her another 6.
Yeah, it's not worth it, right?
Well, the old system, you picked where you wanted the seam exactly. So you would pick it where there's no really bright stars.
Yeah.
You would say how quickly you wanted it to feather, and what sort of how well you wanted to trace the gradient over both the images. Well, you could fix a lot of sins having that control. Now it's just, okay, put your 2 images in here, and that will spit out the result for you. And you got, well, okay, well, I've got no control now.
Yeah. It's more turnkey now, right? They want you to just throw it in and it fixes it for you.
Yeah,
right?
yeah.
Yeah, you don't control it.
So I don't use their gradient correction tool either.
Yeah. I don't know why people are so resistant to certificate signing, like I know in some cases it costs money. That's probably why they don't want to do it. So
What is certificate signing?
there's a way of certifying a piece of software in Windows so that you're not getting like, I don't know, like viruses and spam
okay.
and stuff. So really what the certificate is, it came from the individual that built it.
Yeah.
So for instance, if Celestron had a piece of software
Windows knows the developer, Windows doesn't know the developer, right?
Exactly. So it is just like it's a signature. It's like, oh, I signed it. This is mine, and you got it from me, so it's okay, right?
Gotcha. Thank you.
That's stock Windows stuff. So I don't know. I do kind of secretly hope that everybody goes to Linux. Actually,
when I was using Unix, that was the future, right? That was everything.
Same here.
Would be a Unix workstation.
Same here. When I got out of school, and this was in the early 80s, when I got out of school, I was a Unix guy. And then I ended up working, and then I became a mainframe guy. And we used MVS, and we used all these kind of IBM proprietary specific OSs. And then finally, 15 years into my career, we get workstations that use Unix, but Sun Micro Systems Unix. Well, you guys would have used, like in the oil industry, you would have used Sun Microsystems.
Well, I remember the UNIVAC at one time.
Yeah, that's there were PDPs, like VAX was really big in Alberta. So I looked after VAX VMS systems for quite a while. Because our cartography, like all our GIS stuff, was Intergraph based, and they use VAX 780s or whatever. Anyways, they were or 750s, I think there were. So they were the thing, but I never got to use Unix for quite a while until deeper into my career.
But I was writing, I remember it was 1990 and 1991. I was writing well testing software over in Holland. And it was all done on the Unix, and we had a GUI toolkit so we could make our own GUI stuff. And that's the way the world was going. It wasn't personal PCs. It was going to be Unix workstation. So basically a personal PC on steroids that would run Unix. And we were going to get rid of all the mainframes.
I think the PCs really caught people by surprise. I don't think they realized how ubiquitous they would become.
Yeah.
I don't think they knew that.
And how powerful they would become.
Yeah. Yeah, that was a bit of a thing that people didn't realize would happen.
Yeah. Anyways, I'm going to hit the road too.
Okay.
Sounds good. Very interesting. Thanks for the talk, Dave.
Yeah, I hope
Yep.
it was interesting. It wasn't too dry, was it?
No,
Not
that's
at all.
Okay.
rabbit holes are always good.
You hurt my fucking head. Good night.
Good night.
Okay, bye.